Okay, this is Durwood King of Sampson Community College, and this class is ELC 130, Advanced Motor Controls, and we're going to go over our COVID fact sheet that the school has sent out to everybody. COVID is sort of making its way around again, close by. It's affected a few students, as of right now, as you know that. So let's go over the fact sheet, and I'll print that also if you want it printed. But it's available on the main page for the college on the SEC website. And let's go over our guidelines for that, and then we'll cover the syllabus, and then we'll get into our first chapter. So thank you for joining those of you that are watching. Cameron, if you're watching recording, just let me know, stay in contact, what's happening with you, so we can keep you up with everybody. And thank you, Roger and Dylan, for joining. And so we'll do this until everybody gets back. So we're good to go with this. Okay, so let's look closely at our COVID facts. Lots of questions. So what will happen if I, as a student, am exposed to COVID-19? If you have come in close contact with someone who has symptoms, which would be a cough, shortness of breath, difficulty breathing, chills, repeated shaking with chills, muscle pain, headache, sore throat, loss of taste or smell, fatigue, congestions, runny nose, nausea, vomiting, or diarrhea, or has tested positive for COVID-19, you should remain home and seek medical guidance. The student should also submit the COVID-19 self-reporting form. Now you see that blue link there? You click that link, you go to the main college website and you click the link. Now here's how you get to the link on our website is we go back to here. And let's go, there was a link directly on the main page. Let's back up here. That's the financial aid thing. For those of you that might not have known it, there was financial aid available for everybody this semester. Now, when you scroll down, well, I guess you have to get the X dot out and then scroll down there right here. So here is where, when the red bar, everybody look at the red bar. This is where you go to self-report at. COVID-19 updates and announcements. And you guys, can you still hear me good out there, Roger and Dylan?
Yeah.
Okay, good. I'm just double checking because I got a mask on and I'm sort of facing the other way. If you hit a point where you can't hear me very well, let me know, because I don't really know when I move around if I happen to get to where you're not able to hear me well. But we shouldn't have any. Okay, so y'all see the red bar there?
Yeah.
Now we're going to click that, and it gives you the update. Now, the self-reporting form. So right there, when you click that, self-reporting form, if you've had symptoms or tested positive, procedures below are to be followed. If an employee or student has received the vaccine, then you open this one up. You follow that guideline. If employee or student has been diagnosed, then you click the link right here, and there goes the self-reporting form. Everybody see that? So that's how you get to it in there. You put your name, and then you hit next, and then you follow through and answer the questions that it has for you. Okay, everybody good to go? So that's how you get to it. And then that. If the employee or student has been diagnosed with COVID-19, they should submit the form, and you would be excluded from work or class until you have no fever or at least 24 hours since your recovery without the use of a fever-reducing medicine, and other symptoms have improved. At least 10 days have passed since the first symptoms. Unless considered a close contact, other students and employees can remain on campus, but should monitor for 14 days per the health department. If an employee or student resides with someone who has been diagnosed with COVID-19, so if somebody in your house has, you submit the self-reporting form, and then you will receive appropriate guidance. Based on vaccination status or experiencing symptoms, the individual will receive appropriate guidance. So the college will be in contact with you if you do a self-reporting form. If an employee or student has been exposed to someone who has been exposed. So if you have been exposed to someone who has been exposed to someone who has it, contact by contact, then the employee or student can remain on campus, so you can stay on campus, but you should self-monitor for 14 days per the health department. And then lastly, if an employee or student has been in close contact with an individual exhibiting COVID symptoms, and that individual is waiting results, then if the employee or student has been in close contact with the individual exhibiting the symptoms, and that individual waiting for results, the employee or student can remain on campus. If the results come back positive, then the student or employee should submit the self-reporting form with the updated information and refrain from campus. Now, there's also another form that you got to fill out to be able to return to campus. So there's a return to campus form that you got to do to get permission to come back on campus. And let's see where that is. They're not showing that actual form in here, the one that you do to get back on campus, but that you would be in contact, they would be in contact with you, and they would let you know how to, as far as filling out that form. Let me go back to the email. Let's finish reading the let's finish reading the fact sheet. Okay, let's continue to read on the fact sheet. So you would self-report and consult with the instructors about continuing your coursework. If you've had a test and you're waiting results, the student should immediately submit the self-reporting form, remain at home until the results are determined. If a student tests positive, should remain at home and must immediately report. The COVID response team will review the form submission and respond accordingly. And so that response team will communicate with you, and there's also a direct number there, a 900-4329 you can call and email. Will my absences be excused related to COVID-19? If the student has to remain home, every effort will be made to ensure that the student continues all your coursework. It may include allowing the student to complete assignments remotely, which that's what I'm going to do. Absences incurred will not violate your attendance policy. So no, it won't be an issue as long as you have contacted us. In most cases, instructors, department chairs, and so on will discuss what options are available. Should I access myself for COVID-19 symptoms? Should I assess myself for COVID-19 symptoms every morning before reporting to campus? Absolutely. Assess yourself each morning, determine if you may be experiencing symptoms, which we've already been over the symptoms there, you know, cough, shortness of breath, difficulty breathing, so on. Must I submit a health screening when I arrive to campus? Certain areas require screening. Other areas are encouraging you to self-assess each morning. So I don't do any screening. You just need to be monitoring your own self. The main thing is you got to have a mask on. You have to have a mask on. So could I be sent home from campus if I'm displaying symptoms? For the safety of everyone, as well as the community, student who is displaying symptoms may be sent home with CDC guidance regarding self-isolation directions to seek guidance from a medical provider and when it will be safe to return. Now, student must submit that form, so on, so on. How is SCC reducing the risk of exposure? You wear a mask, wait, wash. Employees are required to wear face coverings inside campus buildings. So if you're inside a building, you got to have it on. Employees may remove the covering when you're by yourself. Virtual services are available. Hand sanitizing stations are available. Does SEC require a 48-hour COVID testing? Rapid tests are generally less sensitive. Therefore, individuals' symptoms and or known exposure must confirm negative results with a PCR 48-hour test and or follow quarantine guidelines. If you've been exposed to COVID-19, you can be around others after 10 days since the symptoms have first appeared or confirmed positive, and 24 hours with no fever, without the use of fever-reducing medications, and other symptoms are improving. So that's how you're going to know as far as you being to come back. Now, there's a form you got to fill out online also, but that's how you'll know if you're ready to come back. I'm going to print this also. And let's see. So I'm printing paper copies of this. That way you can have one and not have to go to the website and look for it. Now, quarantine, close contact with a confirmed positive. Are you experiencing symptoms? These are the questions. If you are, you must quarantine for the full 14 days from the last exposure, unless you test positive. Are you experiencing symptoms? No. Quarantine is based on vaccination status, see below. Second consideration, are you fully vaccinated? If you are, if you've been fully vaccinated and you're not showing symptoms, you can remain on campus, but you must wear a mask at all times. 14 days post-exposure, and you should receive a PCR test 3 to 5 days after exposure to confirm negative. If you're not fully vaccinated, I guess maybe if you just have one shot. If you're not fully vaccinated and you are not showing symptoms, you're not showing symptoms of vaccinated, you may quarantine 10 days without testing from the last exposure, quarantine 7 days with a negative test on day 5 after the last date of exposure. This is all so complicated. So I'm just going to give you a paper. Hopefully nobody will deal with it. Very few people. Don't be putting so much time on this, but they said I had to go over it. This front back. There's okay, now we're ready to get started on our any questions. I know you don't have any questions about that because we said it. Okay. So that would be the main part right there, guys, right there, that if you've been diagnosed with it, you can be around others after 10 days since the symptoms first appeared or confirmed positive, and 24 hours with no fever without using medications, and your other symptoms are improving. So basically 10 days after you've been tested, if you have been tested positive. That in the gray would be the main thing there. Okay. And then as far as being around someone that tested positive, you would self-report and then do the self-reporting form and wait for your test result to get back and then go from there. And if you've been tested positive, then follow that 10-day guideline. If you tested negative and you don't have those symptoms, then you would just communicate with that COVID team whenever they contact you and tell them that you don't have the symptoms and that you tested negative, and they'll be the ones who decide to tell you to come on back. And you would do a return to campus form. They would give you a link for that. The link's not in here for that, but that would have to be completed. So, all right. So we're ready to move on from this. So here we go with our syllabus for our class. Sorry for all that, all that stuff there. Would you like a paper copy of the syllabus? I'll print you one if you like one.
I'll take one.
Huh? What, Roger?
I'll take a paper copy.
Okay. Anybody else? Paper copy of the syllabus. Yeah. All right. So anyhow, so here's our outline. It is advanced motors and controls, and it runs from today to November 23rd, 10 to 11:25, Tuesdays to Thursdays. Those are my office hours, 9 to 10, and 5 to 6 on Tuesdays to Thursdays. It covers motor concepts, construction, characteristics, providing foundation and motor controls. It includes motor control, ladder logic, starters, timers, overload protection, braking, reduced voltage starting, SCR control, AC and DC drives, system and component level troubleshooting. When you complete it, you should be able to specify, connect, control, and troubleshoot and maintain motors and control systems. Now, in the same book that you had in ELC 117. Y'all have your book? Still have your book? Everybody does? Okay, good. Nathan, you still got yours? Your book? Yeah. Okay, good. Right. So it's the same textbook. We continue. That's the book. Dylan, do you have yours? And Roger?
Yeah, I got mine.
Great. So we're going to pick up
Yep.
at chapter 12 on sequence control. So we'll pick up from there, and there's a lot. There's a lot in this book. So it's a good thing you didn't have to go buy an all. You know. All of you have your book with you today? You do? Okay, great. Okay, that's good. And let's see what else. I forgot anything yet. I've got the Zoom recording going, COVID fact sheet. We're doing the syllabus now. Everybody's got books. Okay, great. Now, so we're ready to get into it. So we're going to start out in chapter 12 on sequence control. And then we jump to 36 on VFDs. Y'all remember doing the variable frequency drives out here? We will go right into that. And we're going to spend a lot of the semester on that. Now, also braking. Braking is going to be tied into your VFDs. I've got brake resistors, which are right here. Inside there's a big wire wound resistor in there. It's tied to the drive, and it soaks up energy when you try to stop a motor all of a sudden. So it'll actually stop one like servo does. You'll be going along at full RPM, and when you hit that stop button, it goes whoop. It just stops like super fast. So the braking, we have electronic dynamic braking, and also we got a motor that also has a mechanical brake pad on it. So we have mechanical type braking, and we also have the electric dynamic braking like that. We'll get into it in that chapter. I got brake resistors like that in place for all of the drives. You got brand new drives, the Allen Bradley PowerFlex 525s that have 3 types of ports on them. They have a USB port for programming. They have a serial port, and they also have the Ethernet port. And I have the double Ethernet ports I've added in there as an add-on module. You'll get into how to configure those Ethernet ports, how to control them from the PLC. And so this class is going to be like a combined motor controls and advanced PLC, all that combined. So once we get into the class in a few weeks, you'll have the laptop, your PLC, the newer compact logics like you used last semester. You'll have that in front of you. You'll have an Ethernet switch, and it's going to be tied into the drive. And you'll be doing that advanced type of control via Ethernet. And then also beyond that, you'll be setting up programming these panel views, these touch screens like this, Panel View Plus. These will also be tied into the PLC, and you'll learn to run this to program buttons on here instead of having physical buttons and wiring them. You'll have a touch screen with an Ethernet port, and that's going to tie in. That's called an HMI. It's a human machine interface. And a lot of plants are using the touch screens. This is advanced stuff here. I've got 6 of these for y'all to use. I have a total of 7 of these, and you'll enjoy this a lot. There's a special software package for this. Factory Talk View Machine Edition for this. You'll learn a new software package. Anyway, so the HMIs is another thing that's going to be an important part of this class. So there is a ton of stuff ahead to do. There's a lot of stuff. Now, after braking, we have float switches and liquid level sensors. I've been getting some feedback from guys that's been going on interviews, like over at Goodyear, that they've been saying that they've got like advanced float control diagrams on the entrance test. How many of you have seen that test? I know I've had a couple guys that have told me that they had. Well, Dylan, didn't you say you saw advanced float controls on a Goodyear exam, Goodyear test.
You said advanced flow controls?
With on floats.
It was, I think there was 1 or 2 questions with floats. I got it wrote down somewhere. I have to find where I wrote it down at what was all
Right.
on it.
But we've got an entire chapter on float controls with the float switches and all, where I've got a lab, I've got a whole bunch of floats that I've ordered out here. And you'll have your lab on floats, you're going to have four different levels of floats in a tank. So you'll wire in 4 floats to your control. It's going to control the level in a tank by way of four different floats and a couple of starters with 2 pumps, 4 floats and 2 pumps. So I've got quite a bit of stuff out here, ready for that. Also, DC motor controls. I've been hearing some reports about people been going on job interviews, Goodyear, and they're asking about what do you know about DC motors. So Luke helped me whenever we ended the last semester to get some things down from upstairs, up here, and we had some DC motors up there and some DC drives that we've never used because they haven't really been requested very much, being that we have the AC VFD drives. So, but we got DC drives now, and you'll learn about how to wire those up and test those. So DC motors, motor controls and motors. Another thing would be Y delta starting. That's chapter 20. All of this is in your book. It's in the same book. Y delta starting is an advanced form of motor control that's in your book in chapter 26, and that comes in from Schindler. Dylan was at Schindler, and we have about 4, and Nathan's at Schindler. You still there? Are you familiar with Y delta controls? You've seen those? Have you wired any of those or just saw them?
Well, I saw them. I'm not wired for them. I'm not on the floor. I'm
Doing something different. Okay.
He's wired them in. I know for a fact he's wired them in.
Right. Okay. At least you're still in there. But with Y delta starting, that's a way of doing a soft start and a hard run with a 2-stage starter system. And I've got a schematic that came from Schindler that Gary McClanahan got. You're going to set up a Schindler circuit and wire that from scratch. Now moving right along. Single phase motors, we're going to go back over those. Beyond that, you got pressure switches, sensors, flow switches. All of these are chapters that are in the book. That whether we actually get to all of those or not, I don't know. But the main heart of things that we're going to cover would be sequence control, a lot on VFDs, a lot that would incorporate the PLC, the HMI, the VFDs together as a network. Braking would definitely be a part of it. Float switches and liquid level, DC motors, Y delta starting. Now, those are the main meat and potatoes that we're definitely going to cover. These other ones are other things in the book that I had to lay out enough to show. The college wanted me to show them a whole semester of what we're going to do in a timeline, and it's subject to change, and it's going to have to change. We're not going to cover everything that's up here. I already know that as I'm getting into it, because we're going to put so much time in VFDs. So these additional ones in here are things that I stuck them in there just to show a timeline and a guesstimation on what we're going to do through this, so upper management can see that I have a plan. But it's also subject to change. These other things, we'll get in what we can. Now, the additional material that's not in the textbook, very important, would be the panel view I just showed you, the HMI touchscreen. That's not in the textbook. We're gonna do it. Okay, you got to have it because that stuff is out there in those plants. And you got to have it. So this extra material that I'm putting in, touch screens, and then servo drives and servo motors. That's something that's not in the book, but I've got 3 servos. I got them right up here. I got 1 servo set up here that I've got to get familiar with it and, get time to do that. But we're going to include that in this class. So servo drives are ones that are motors that have encoders on the back of them that tell the controller where the motor is. In a lot of detail, so you can do a very precise positioning with a motor that has an encoder on the back of it. You know, you have, it's a feedback device that tells you control exactly where it is, so you can tell that thing to go a precise amount of movement in thousandths of an inch, and it'll stop right where you tell it to. So that's, in a nutshell, that's what servos are good for. It's for precision positioning, very accurate positioning. So that's, you know, that's something we're going to work in. That'll be on the very tip top. The most advanced part of class would be that. Okay. Now, so moving right along, your outcomes would be wiring, testing, troubleshooting sequence controls, PLCs via Ethernet connected to the motor controls, understanding soft starters. Soft starters are an economical form of a VFD. We have soft starters that you wire and program. It's called reduced voltage. SCR is how it works on the inside of the soft starter. For VFDs, that's going to be the main part of our class. Understanding the different ways of controlling the VFD by way of the keypad, and then wiring, and also by Ethernet, speed pot, 40-20 current loop, braking. Now, that's giving you the goals of the class. You've already got your textbook. Just make sure that you have safety glasses, that you wear a mask every day. If you will, go ahead and do your syllabus acknowledgement quiz in Moodle. If you could do that today, go in there and click that one question that you have that you agree with the policies. That's the weights of the class right there. Test 30, quizzes and participation 10, labs are 30%, worksheets are 30, and so on. And as far as the attendance policy, it's the same thing. Late assignments 10% if it's a week late. You're allowed to miss 15% of the class without being dropped. Everything else is the same. That's a general guideline of a timeline of what I was guessing that we would do. Now, we're not going to be able to actually meet all of that, because we're going to put more time on the earlier ones than on the later ones. So there'll be probably several of these in here that we don't even do, so that we get more time on the main things like the VFDs. Okay, so don't get worried about all of this. It's just something I had to. They're requiring me to tell them now what we're going to do each week and when things are due. But at the bottom, if you look right here, subject to change, and it will change. We're not going to cover as much as it's showing in here. Okay. Those are your links you can click if you have trouble logging on directly to our Samson web page. You can go to my Moodle at samsoncc.edu and get straight into Moodle. Your email can be accessed from office.com directly without going into the website. Okay. So if everybody's good with that, you would go into Moodle and let's see. That. Another 130. Now this is our Moodle page for this class. Just simply go in there where the acknowledgement quiz is. If you could go ahead and do that now, we'll make sure you can get it done today. The syllabus acknowledgement quiz, there ain't but one question in there. And all it says is I have read and understand the syllabus and hit true and then submit it. And then you'll be covered. Okay. I don't have a worksheet in there yet. I'll have Roger and Dylan. I'll have the worksheet in there for Thursday. Let's go ahead and get into chapter 12 now, and let's cover what we can of that. So let's minimize this. And so we're going to chapter 12 in our book now. Now, so here we're getting to the meat and potatoes now. Sequence control. Everybody watching. So we're getting into our material now. Chapter 12. We're going to look at the purpose for starting motors in a predetermined sequence. How to read and interpret sequence control schematics, and how to convert a sequence control schematic into a wiring diagram, and then you'll connect one. Now, sequence control, here are two reasons that you may have sequence control on motors. Why would you have to have one motor started before some other one in a particular order? And one example would be if you have a hydraulic press. So on a hydraulic press, if you look on page 142, so let's go to 142. Now, your example on 142 says that hydraulic presses that must have a high pressure pump operating before they can be used. So in other words, a high pressure pump's got to be on first before you can turn on some other motor on the press. Also on air conditioning systems that require the blower to be in operation before the compressor starts. So for air conditioning systems, the blower's got to be on first, and then the compressor would be allowed to come on at that point. So those are two reasons for why would you have a particular order for a motor to come on in. There are several methods of doing sequence control. Now let's take a look here, guys. Pay close attention. Now, do y'all see really good? Everybody watching screen good? Let's discuss how the circuit works. So, what do we have up here, guys, from ELC 117? Can you tell me, Roger and Dylan, do y'all still want to hear me and see me good?
Yeah.
Okay.
Yeah, I can see.
Y'all see it good? If y'all will interact with me some, let me get some feedback. What do you see up here for motor one? Does that look familiar from ELC 117?
Yeah, you got a starter.
You have a starter consisting of a contactor and overload. You got a motor. Here you got three motors, not just one. Now let's look in the control section at what we have here, guys. So we got three-phase power up here. It could be 240 or it could be 480, right? Now you bring the three-phase. The three-phase goes to all your starters. It also goes to a transformer. We're going to step it down to say 120 volts AC. Now, when it gets down to 120 AC, this is what we want to analyze now. How does this work? So I want you guys to tell me, we got a stop button and we have three start buttons. What would happen if I went in here right now and I tried to start motor number 2? Would motor number 2 start?
No.
No.
Can you tell me why it would not start?
Circuit's not complete.
The circuit's not complete, and so what would it take? What do we need to be able to hit that button and the second one start? What do we need to have?
Press
Motor
one.
has to be on.
Motor one has to be on. So this is to where if you have a hydraulic press, for instance, and you got to have a high pressure pump to come on first, one end would be the high pressure pump, and then the two end would be some other motor on that hydraulic unit. Okay, where it's a multiple motor press. Okay, so somebody tell me, what do I physically got to do to get all of them on? How does the circuit work?
Looks like you gotta press the start button for motor one.
When you press number one, everybody look. When you press number one, you're going to energize what?
Motor, the Ain't it the starting contact or whatever?
You energize, what is that symbol right there, that round symbol that says 1M? What is that physically?
Oh, that's the motor.
Well, it's the coil for the starter. It's the coil for the motor starter, right? The motor's up here. That circle would be in the motor starter itself. Let me get a loose starter. Okay, here you go. Let's take a look here. Y'all remember this? The motor starter. Now, the motor starter has a coil, this A1 and A2. The terminals are A1 and A2. Y'all remember wiring that up? When you put power from, when you leave the start button, you're going to go to A1 and A2 on the starter, and that's the actual coil that's back in here. You remember that? Everybody good? So that's not the motor, but it's the actual coil that pulls the starter in. When you put power there, it draws the contacts in, and then any contacts that are labeled 1M, like the holding contact, it'll pull in. But what about up top here? This says 1M. What happens up in here when that 1M pulls in? That coil. So when the coil pulls in, we know that you get a holding contact around the start button. This would be terminals 13 and 14 on the front. You remember wiring that up? That's your 13, 14 holding contact on the front. But at the same time, that 1M does what up here?
Energizes the motor.
Yeah, you get all these 1M contacts come on, which are the three big ones up in here. Remember that, everybody looking? Everybody watching? Nathan, you watching? Everybody? Your three big contacts up in here. So they end up getting through the starter, through the overload down here, and then they end up getting to the motor. So by pressing number 1 button, you get this one pulls in, holding contact pulls in, and that one runs. Now, what happens? What do I do next to get the next motor on? Let's put some writing into here where we know that.
You got to press the second button.
Look, when the 1M kicks on, look here, guys. When the 1M comes on, the holding contact, this is going to be made. Let's put some drawing on this so I can draw. So let me hit the escape and get it so I can actually draw. Let's go this way. Now it'll let me draw now. Can y'all still see that pretty good?
Yeah.
Yeah.
Good to go?
Yep.
Okay, now, so I can draw on this now. So look, when the 1M kicks in, that's going to be made, and all of these are going to be made, and that one's going to come off. So now, when you go to press what happens here when I try to get the second one running?
The second set of contacts are going to be made.
Right, the second set. Yeah, when I press that button right there, the 2M coil is going to kick in. It's going to be the next coil here. It's going to kick in, When it does, then the 2M contact's going to kick in here for holding contact. And then also these will come on, right? When they come on, your second motor comes on. So the 1M holding contact for the first one is actually a permission contact to let the second one come on whenever you press the second one. Everybody got it? So now the second one's running, and how about the third one? How do I get in on? I press button 3, and since 1 and 2 are on, I press 3. That's going to come on. The third coil, that coil is going to kick on. That holding contact's going to kick on, and then up here you're going to get these 3, and then that motor there is going to come on. Everybody good? Now this is manual sequence control. Okay, that's the way to do it manually. Let's take a look at our next circuit. I'm going to go back to the bigger screen. That's kind of harder to see there. Let's go back to full screen. And let's get this. The next circuit is a variation of the first one. Can someone explain how this works? Let me get a volunteer to tell me how this works. You get the same result, but it's a variation on the way they got it wired and designed. So can someone maybe make an attempt at explaining what would happen if I went in here and pressed number 2? Would it let it run? Who says yeah, who says no?
No, it's not going to run.
It's not going to run.
Because the contact with motor 1 has to be made, and you have to press the first button for that to happen.
Exactly. So look, you got something called a permissive contact, or maybe even an interlock or permissive. And what that means is, before this can happen, something else has to happen, which is sequence control. So Roger, what have I got to do here? You said I got to do what?
Got to press the first button so the motor starter can have power go through it.
And what happens here? The coil, not the motor itself now, but the coil, the A1 and A2, it's going to kick in. It's going to seal in around here. And the first motor, which the motor's not shown here, it would be up above it in the 3-phase section. This is just a control section here because you've already seen the motor section. The 1M kicks in. That's going to make your motor come on. This on the upper section of the diagram. And then what happens if I try to start number 2 now? It'll start. It will. Does everybody agree with that? Why will it start?
Because your auxiliary is pulled in.
Your auxiliary is pulled in. Look, that normally open, which would be like 13 and 14 on the front of the starter. That would be your holding contact. But actually, yeah. Actually, it would be when you have a 1M here and you've got a 1M here, there's 2 normally opens. Guess what you have to do if you're going to do that? You got to put an auxiliary on the front of this, which let me grab one real quick. You have to do an add-on contact to give you another normally open, to give you 2 normally opens. Okay, watch closely here. Because this starter only has one normally open auxiliary, it's 13 and 14. You add another block on the front of it like this. If you look here, guys, this add-on block, you take the front off, and then you slide. The auxiliary is going to slide in there. Take my I got red tape on here for I was doing for Zoom for people to be able to see it go in. Get my tape off of there. Now, so if you watch right here, everybody watch. You've only got one normally open on the starter. So to get another one, you get a Snyder brand extra auxiliary, and it slides onto the front like this. It snaps on. So it's like a third level. You know, have your L1, 2, and 3 for your motor. You got your auxiliary and your coil, and then you have a third deck to it, like a third floor. And so what happens here is when the coil kicks in, look, it also pulls in this other auxiliary with another normally open on there. So can you see that good, guys?
Yeah.
Yeah.
So on the front there, you have a NO, which would be the 53 and 54. Y'all see those numbers over here on this side? That's another normally open, normally closed, another NO, and then you have a normally that's normally open over here, and then another normally open there. I mean, a normally closed on the right, and a normally open on the left. Okay, now I'm gonna pass that around. Your original normally open would be 13 and 14. Then you have a normally closed, but you need two normally open. Okay, so you have this on there, it pops on like this, snaps on, and see it follows. It follows this action mechanically linked, and it could be 354 would be another normally open. That's two normally open.
That would be like, if you're troubleshooting something, you would have to have one of those check.
You would, yeah. You see how it locks in? You got a blue thing there, a little catch, and that's how it attaches. It'll lock in. Hear that lock? And then when the other pulls in, it pulls it opposite, it follows. See how that goes there? You got your normally open 13 and 14, but you need two normally open. That's normally close. You got to put that. That's called front mount auxiliary that you can add to the front. Some starters have on the side. You snap on the side, Allen brand is on the side or the front, and the Snyder is on the front. Okay. So that's telling them that some starters have actually side mount auxiliaries that snap on the side that link in with the armature, but then this is a front mount. Okay, so they're different styles. Now moving right along. So you're basically what you would have would be here. Your 13-14 would kick in. It's down in here for holding contact, and then that one in would also bring in the 53-54 up top. It would give you the extra auxiliary up top here as a permission to allow to let you choose two. So it's almost like another stop button, basically, that if it's not made, you won't run. So if I hit 2, what happens? Right, you get the 2M kicks in, the 2M holding contact will kick in, the second motor will run, and then also down here, this other 2M, your second starter would also have another one of these on there, another add-on, another extra auxiliary, which should be here. You got your regular 2M holding contact here, 13-14, and then your additional one on the front would be here, a permission contact for 3. So when you press the third button, what happens?
Motor start, contact.
Right. The third coil will pull in, and it's going to make the starter pull in that holding contact, and then you got all 3 motors running. So this is another form of manual sequence control, not automatic. The next command is going to be for automatic with timers, which will be where your lab will be. Well, you do your first lab Thursday. We're going to have you wire a timer sequence control that's coming up on your next diagram. So any questions here? So what happens? We know we had to cut them on in order, but what happens when you hit the stop button? What goes on? it breaks all the holding contacts. And what happens to the motors? All the motors, are they going to shut off at the same time? They will. They're going to shut off at the same time. So you cut them on in order, but when you hit stop, they're all going to quit at the same time. They ain't going to be quitting in a particular order. Now, in this chapter, there is a circuit with timers that lets it start in a particular order with delays. And then when you hit stop, that's going to stop them in reverse order with time delays between them. That's an advanced lab that I have that you can do that does delayed timing on startups and order, and also a reverse shut-off order. So everybody good with this? Now, next circuit.
Yeah.
Again. Now look, we went from the permission contact. Look closely here. The permission contact was after the start button on this circuit here, right? It was after. Now they're going to move it over before, and they're going to do a variation of this same exact circuit. It's very simple. So look at this right here. See that? The difference? That's what you had before, and now they just moved those auxiliaries to the left. You see that? So is there any difference in the way this works? Or does it work the same way?
Not that I can see. It looks the same to me.
It's going to be the same thing. When you hit the number one push button, the 1M is going to kick in. Your first motor up top is going to kick in. That gives you the holding contact. Also, the 1M is going to pull in your extra auxiliary on your third level here. It's going to pull it in here, right? And then it will allow you to manually start number 2. All they've done is they have moved the auxiliary from here to ahead of it instead of after it's ahead of it. You still have to have it. It still has to be made, right? And it doesn't matter on which side of the push button it is. It gives the same effect that you have to have it on. Now, so when you hit 1, it seals in. It brings that on. It allows you to do number 2, right? If you press 2, you get a sealing contact, and then what does 2 do? It gives you a holding contact here, and also a permission contact down here that lets you hit 3. Everybody good? So functionally, it's the same as the one before, right? Functionally, it's the same. It just moves the order of where that contact is. Now, automatic sequence control, it allows automatic starting of motors in a sequence, and it is common. It is common. There's several methods of doing this. So this is the first one. This is your actual first lab right here. So you'll do this Thursday. And I want someone to tell me if you remember, how many of you remember doing timers in ELC 117? I'm not sure if everybody did a timer. I don't think you actually got to it.
Yeah, I did. I remember timers from ELC.
But not hardwired timers. Now this is an 8-pin hardwired timer, 8-pin base with an 8-pin socket, like for relays. And this in this case, you'll have Thursday, you'll have 2 timers and you'll have 3 motor starters on your board. Okay. And so here's how it works. It works the same way as it does in PLCs, but it's a physical timer this time. So who can tell me, Luke, can you tell me how this thing works? You still got 3 motor starters of 1M, 2M, and 3M, or dealing with someone who can tell me how this thing works. When I press the number 1 start button, tell me step by step what happens here.
You get push button 1, holding contact.
Right, when you push the number 1, the 1M coil is going to kick in, and that holding contact is going to seal in, and then what? The timer will start. Timer 1. You're talking one of these plug-in timers with an 8-pin base. And I've got a handout up there on the table, a reminder of the layout of the pins and all of the timers. But this is from chapter 11. You know, we're in 12 now. Chapter 11 was on timers. So it gives you the layout of what all the pins are. So the timer has a coil and also has contacts. So you said it's going to start that timer, and then kind of give me some more information here. Now we have a setting on the timer, right? We have a dial. And what does that dial mean? If I put that dial on 5 seconds, what does that mean since you pressed that start button and you got that timer coil in parallel with the number 1 coil? We know that there's power there, and that timer, you said that timer's timing. It is. So it's going to time, and when it gets up to 5 seconds, what happens? Hmm?
Your
Yeah.
contact is gonna close to pull the motor 2 coil.
Now look, where it says TR1, that's the coil inside that timer block that you've energized. After 5 seconds, where it says TR1, this here says TR1. That's a normally open contact with an up arrow. Here's what it means. After the 5 seconds, this contact with the up arrow will move into up direction, and it, like Dylan said, it's going to make that close. The TR1 coil controls the TR1 contact. Everybody good? So when it comes up after 5 seconds, what happens here? Motor 2 starts, the coil for the second starter pulls in, which means the second motor is going to run. At the same time, what's happening with timer 2? It starts up timer 2. So your lab, and you will go, you're going to go right straight to wiring the lab. As soon as you get in here Thursday, you go right out there. We're going to set you up with 2 timers and a motor starter. Look at here. So number 2 starts. And what happens after 5 seconds?
TR2.
The coil for TR2, the coil, it has made this internal timer time. And when it reaches 5 seconds, you said, what happens here?
It makes contact.
It's going to go up in the up direction because that's an on delay timer. When you see a timing contact with an up arrow, it means that it's going to move in that direction after the time lapse. So after that 5 seconds, it moves up, it's going to be closed, and then what happens here? Motor 3 will start. So this is what you call automatic sequence control for 3 motors, and you can select the amount of delay between those physically with that. Now, this is like a first level of sequence control. When you hit, there's several levels of this. When you get further with it, you're going to write a program on your with the PLC, and you have the PLC to do PLC timers, and the PLC is going to run the starters. Okay, you see, so we're going to do it completely hardwired to begin with, and then you move on. We're going to take it in steps, and it's going to get a little more advanced as you go. Now, what happens when you hit the stop button?
Press on contact. And it should shut them all off.
When you press this, it's going to shut all of them off at the same time or in order?
Same time.
At the same time.
Am I doing?
Now, there's
My next customer.
yes, sir. Yeah, we'll see. We'll see. Yep. Now, any questions out there, guys? I know this is both of you were good to go on timers, but this gives you, it's just, we're picking up from where we left off in 117.
I
So
don't think I actually did the lab, but I understand it.
did you actually do it in 117? Okay.
No, I don't think so.
We didn't even get to this chapter. We didn't get this far. So that's why we're starting where we are. You know, we're starting right where we left off, and we move on forward with it.
Gotcha.
So anyway, we will. I've got the National Electric Code. I'm going to have you a Zoom session. I'm going to set the Zoom session up now, and that class is going to start, I think, at 1 o'clock. Let me see. The code class starts at 1 o'clock, and it lasts for 55 minutes. So it goes from 1 to 1:55, National Electric Code, ELC 118. And then the
What about,
ELC,
I was going to ask about AC/DC.
and then the AC, the DC and AC electricity, it starts at 2 o'clock. and it goes to 4:55. So it's almost 3 hours. Yeah. We really needed 3 hours for this class, you know, an hour and a half for the DC and the AC, but it's not anything. It was over my head when that got picked. So we'll work with that time. And I got a hunch that what we're probably going to end up doing is probably taking some of that time in the basic class, and some of you guys that have already had a lot of that, maybe use some of that time and let you sort of get on to do some more advanced stuff. And we'll see how we can do as far as borrowing some time whenever that's allowed to maybe borrow some to do some labs for this class. Okay, for those of you that are ready for that, you know. So we'll see how all that goes. But I got a feeling we're going to be doing some borrowing the time to give you more time for these labs. Okay. So anyhow, we'll pick up right here Thursday. I'll have the Zoom out in the shop, and we're going to be looking at folks wiring this particular circuit and then running it, and then I'll bug it. I'll bug that circuit. So I'll bug it for the next class, and we'll get into our troubleshooting. For this chapter, we're going to have several class periods on this chapter. It gets into shutting these things off in a reverse order with timers. So it gets way more complicated than this. This is the first automatic control here, and it's a good one. So I think it's a good idea at this point to actually go ahead and do a lab, you know, Thursday, and get that under your belt and get familiar with it, and then we go to our more advanced ones of this also in this chapter. So thanks for watching. I'm going to upload the recording later today for Cameron, and so anyhow, we'll see you guys. Just keep me updated, and I'll see you, Roger. I'll see you at 1 o'clock, and also at 2. So thank you for joining. Hope you get feeling better real soon.
See you.
Yeah.
See you, Mr. Durwood.
Thank you for joining, and we'll keep doing this until you guys get back. Okay.
Careful.
Thank you. God bless you. Any questions? No, I don't think so.